Hello, I'm Farhad Fallah from Aldec company. In this video, I'm going to show you how to connect Partition's logical connections to the physical connections on the Multi-FPGA's prototyping board using Aldec's HES DVM on the AWS cloud. In the last video, I showed you how to partition an ASIC designs into multi-FPGAs manually. In today's video, however, we don't go over previous steps, so please watch that video using the link in the description. So the next tab I'm going to explain is the Connections tab. Under this Connections tab, we can configure the physical connections on the board. Today's ASIC designs include significant number of logical connections, and because of the limitations we have for physical connections on the prototyping board, it's a big challenge to connect all logical connections to the actual limited number of physical connections we get on the board and still keep the most optimal latency for the design. This is where HES DVM comes into play to automate and optimize the process for us. So without further delay, let's go over the features that we get under the Connections tab. Under the Connections tab, we have the design ports and also connection pairs. So what is the connection pair? If I go back to the Partitioning tab, over here we can see that direction from one partition to the other partition matters. So for example, from P0 to P1, we have like a bi-directional way. If I hover on it, I can see P0 to P1 we have 1041 connections, and P1 to P0 we have 1172 connections. So we can conclude that direction matters. So we are going from partition 1 to P0 to partition 0, or we are going from partition 0 to partition number 1. That's why under Connections tab we have connection pairs. We can see from P0 to P1 what are the connections that we have. If I expand it, I can see the name of the connections. And also from P1 to P0, what are the connections that we have. We have the same pattern for rest of the partitions. Other than that, we get the design ports. So if I expand it, I can see the design ports right here and the global signals that we have. And we have some columns right here that I'm going to go over them one by one. So we see some out and in different columns right here. The out means the source partition, and then the in means the sync partition or the receiver. The out clocks shows us the clocks that are synchronizing the output port in the source partition. So we can see here, for example, P0 is our source and P1 is the sync partition. The out delay is going to show us the estimated delay from the driver to the output port in the source partition. So the delay that we get from the driver element in our design and all the way to the output port is going to be shown here, and this is the estimation that DVM provides. The out pin is the IO pin location of the output port in the source partition. This is usually defined using the board file. For the destination partition, we get similar values. The in clocks means the clocks shows us the clocks that are synchronizing the input port in the destination partitions. The in delay column shows us the estimated delay from the input port in the destination partition to the sync element. And the in pin shows us the IO pin location of the input port in the destination partitions, and IO buffer and standard shows us the IO pin voltage standard and type of the buffer that we have. Figuring out all of these informations can become very time consuming, but HES DVM can do this for us automatically. To get this done, I just go over Connections tab and click on Analyze Connections. So once it's done, if I open any partition, I can see these values are populated right here. Let's see what each value means in this table. So if I hover on this R column 2, it says rising edge of clock 2. 2 is the ID for the clock. If I go to the clocks, for each clock we have an ID. So in that case, ID 2 is the clock that we get right here. If I go back to the connections tab, it says rising edge of clock ID 2. The next one is the out delay. This delay is 6 nanosecond, is based on nanosecond, and if I want to make any changes, I can just double click on it to change it to any number that I want, but I keep it the default. A means the asynchronous to the partition. So here in the in clocks we have the asynchronous clock, and also in delay is again in nanosecond, and I can make changes if I want. So now we have enough information about each connections, and we need to connect each logical connections to a physical connections on the board. There is also one more tab that we get here. So if I click on it, it gives us more details about each partition. What are the details? So here I can see the number of the logical connections, which is 1041. We haven't assigned it, so we don't see how many direct connections and how many ICC, which is the inter-chip connectors that we have. It's basically the multiplexers that we use, and also unassigned connections. So we don't have anything. There are only 1040 unassigned connections, and the number of physical connections is 353. How many single-ended and how many differentials we have. We get to see all of these details for each connection pair. There are two ways to make these connections between logical connections and the physical connections. We can either use a direct connections or using multiplexer, which we call it ICC modules. So this really depends on the partitions that we are working on. So for example, here the number of logical connections is almost 3 times than the physical connections, which means we don't have enough physical connections and we need to use multiplexer here. But if this number is less than the physical connections, we can connect all of these logical connections to the physical connections using the direct connections, which gives us a higher bandwidth and lower latency. Just to show you how to use direct connections, how to create direct connections, I can just select the signals that I have, connections that I want to connect, and just right click and go to add to direct connections. So these signals are added as a direct connections to my physical connections on the board. So right here I can see the number of direct connections are 5. But what if I want to have multiplexer and connect multiple logical connections to like the limited number of physical connections that I have? To do that, I can select the signals that I'm going to multiplex. For example, I select I don't know, all of these signals up to number 63. I need to right click and click add to ICC, new ICC. So it's going to show me one configuration tab. In this window, first I can define the name for my ICC module, and also I can say if it needs to be synchronized by any specific clock. So here it shows me rising edge of clock 2, so I choose this one. Also I can see the number of logical connections I chose, which was 64, and the physical connections we have for this connection pairs. The available differential is 165 and the available single-ended is 346. Here I can define the number of lines I'm going to allocate for this multiplexer. Depending on how timing critical are these logical connections, I can assign more lines to them. For example, here I just assigned 10. So it means that I'm going to pass this 64 logical connections using 10 physical connections. But if the time is very important for these connections, I can always increase the amount here. I can also define the type of I/O standard I'm going to use for this ICC module, either single-ended or differential. So I keep it as differential. And also the name, by default, DVM uses the standards that are specified in the board definition file that we have. So I keep it as default. And also I can define a start delay for this transmission right here. If I want to keep it just the estimated logic delay that DVM found, which is 6 nanosecond, I just keep it as default. So on the top right side, I see locked or empty. So the empty means that do not generate ICC implementations. So by using the empty, if I just choose empty, DVM is going to just create a wrapper for this ICC module, and at the end I need to write the code for that. But if I just keep it unselected, DVM is going to create the code for us as well. And the locked means that if I hover on it, it just tells me the automatic connections configurations will not change locked ICC. So if I just lock this ICC and then I want to do anything automatically using HES DVM, and nothing is going to be changed here for this ICC module. It's good to mention here that DVM creates 3 types of multiplexers. The first one is just a normal multiplexer where the time is not very critical. And the second one, it uses the DDO registers and it provides us faster communication. And the last one is using the SERDES primitive in the FPGAs. So the SERDES usually provides the very fast clock and also low latency communications, which are used for timing critical signals. So let's create this ICC module and see what happens. So I click on OK. So if I scroll up, I can see here that the ICC1 is created. The type is the DDO registers. The latency is 40 nanoseconds. It's synchronized using the rising edge of the clock, the ID number 2. And we are using the 16 differential physical connections for that. And the logical connections in this ICC modules are, the number is 64. So in our design, we have multiple connection pairs and also a lot of logical connections, and doing this for all of these connections can become very time consuming. But don't worry, HES DVM provides a nice feature to automate this task for us. You can just go to connections and either choose auto connect or auto connect with synchronized ICC. So I'm going to use the synchronized ICC module. So I click on this. It's going to take a little bit of time to create all of this information for me. So now ICCs are created where we need directional connections. They are also assigned. All of this information is provided to me automatically using HES DVM. So if I expand any connection pairs, I can see the ICC modules or multiplexers that are created, their type, the latency that I have. And I can also expand this to get more detailed data about this ICC. Physical connections I'm using is 11 and the number of logical connections are 158. Same thing for rest of the connection pairs. The next step is to define the actual physical pins going out from one partition that has one FPGA assigned to it to the other partition. We need to do this for all the connection pairs that we have. For example, if I expand this one and expand this ICC module, I can see that there are 21 physical connections. So if I open it, I need to assign it, for example, here on FPGA 4, what is the actual pin number, and also it's going to the destination FPGA, which is FPGA 1, and I need to assign the FPGA pin number for the FPGA 1 right here. If I double click on it, I can assign this all manually. As there are many pins on my multi-FPGA prototyping board, I can let DVM automate this for me. Again, DVM uses the board definition file to assign pins to each partition. To do that, I go to Connections tab, and there is a feature here, Auto Assign Pins. I click on it. So I can see that all of the names are populated. And if I expand another connection pair, I can see here as well. For example, here there are 11 connections, and there are out pins and in pins are defined. But one point here is that the design ports need to be defined all manually by the user. I'm using HES board, and I have the list of the pin numbers for FPGA 1, where I have the P0 connected, P0 partition there, which contains the design ports. So based on that, I'm going to enter all of them manually. Okay, so I entered all the pin numbers, and now what I can do, actually I missed one of them here. So I can run the validation to see if all the pins connections are correctly done on my board. To validate the pin assignments, I can go to the Connections tab and click on Validate. In this window, I click on Validate again, so it tells me validation success. So this means that all the pins are assigned correctly to an associated physical connections on the board. Alright, so this brings us to the end of this video. In this video, we covered the Connections tab, and we created ICC modules manually, and then also we did it automatically using HES DVM. We also assigned pins to each connections, both manually and automatically, and at the end we validate them all using the features in HES DVM. Thank you for watching. If you have any questions, you can always visit our websites at www.aldec.com.